Sample problem 3.6 says that farmers base the effectiveness of fertilizers on their nitrogen content. Ammonium nitrate is a common fertilizer. What is the mass percent of each element in ammonium nitrate? So the first step here, obviously, is to write down what we know. And they haven't told us any numbers here. Not only have they not told us any numbers, they've not given us the molecular formula for ammonium nitrate. So the first step I'm going to do is write that formula. So remember, I told you, you have to memorize the formulas for these polyatomic ions, and that's from the table in Chapter 2. And I know that ammonium is NH4 with a +1 charge, and I know that nitrate is NO3 with a -1 charge. So I have to combine those two ions together so that their charges equal 0, and their common factor is just 1, so that means I'm only going to need one of them, right? So I've got NH4, NO3. Now we have a formula that allows us to calculate mass percent. And so I'm going to look at nitrogen first, since nitrogen's listed first in my formula here. So I'm going to look at nitrogen first and see if I can figure out how to calculate the mass percent. So that formula is the mass of whichever element we're interested in. So that's the mass of nitrogen, divided by the total mass of our compound. So that would be the mass of the NH4 NO3, right? Times 100. And now that molar mass of the nitrogen also has to get multiplied by the number of moles of nitrogen from the chemical formula here. Alright, so let me start plugging in numbers. So this is going to equal the mass of nitrogen from the periodic table is 14.01 grams per mole, right? And then I have to count how many nitrogens I have in my formula. I have 1, 2, so I've got to multiply that by 2 moles, divided by, now I have to put the mass of 1 mole of the NH4NO3. So I've got to add that up using the periodic table and see what it is. So I have 2 times the mass of nitrogen, because I got 2 of those, so 2 times 14.01, plus I have 4 hydrogens, so 4 times 1.008, which is the molar mass of hydrogen from the periodic table, plus 3 times 16, which is the molar mass of oxygen from the periodic table. I have 3 of those in that formula there. Equals, and I got that is 80.052 grams in 1 mole of that NH4NO3, and then I have to multiply all of that by 100 to get the mass percent of nitrogen in this ammonium nitrate. So let's see what I got here. I've got 14.01 times 2 divided by 80.052. And then I have to multiply that by 100. What does that equal to? I've got 35% of ammonium nitrate is made up of nitrogen. Now we have to do the exact same thing for hydrogen and oxygen. So let's do hydrogen next, since hydrogen's listed next. So I've got to figure out the mass of hydrogen, which is 1.008 grams per mole. I have to multiply that by the number of moles of hydrogen from my formula here, right? And there's a subscript of 4, so that means I have 4 hydrogens. So times 4 moles divided by the total mass of the ammonium nitrate, which we already calculated when we were doing nitrogen, and it's 80.052 grams. And then I got to multiply that by 100. And let's see what that's equal to. 1.008 times 4 divided by 80.052 times 100, and I got about 5% of hydrogen makes up that 80.052 grams of the ammonium nitrate. And now let's do oxygen. So the molar mass of oxygen is 16.00 grams per mole. I got that directly from the periodic table. From the formula here, I have 3 oxygens, so I've got to multiply this by 3 moles, divided by the total mass again, which was 80.052 grams, times 100 equals, and that's going to be 60% oxygen when I type that in my calculator. And check this out. If we say 35 plus 5 plus 60, that's equal to 100%, which is 100% of our ammonium nitrate, right? All of those percentages, anytime we're doing mass percent problems, all of the percentages should add up to equal the total percent of something, which is 100.